Now what I'd like to do is look at trig identities, proving trig identities that involve conjugates. So what are conjugates? It's kind of a vague term, really. It depends on the application. But what we're going to consider are trig binomials that are conjugates. So for example, 1 plus tangent theta and 1 minus tangent of theta are conjugates. So they're both binomials. Both of them have a term with the same sign, right? The one is positive for both. And then the other term, the tangent theta term, is positive here, while the tangent theta term here is negative. Okay, so they're conjugates whenever one of the terms is the same sign and the other term has the opposite sign. All right, let's see an example involving conjugates and why they can be useful. So let's prove that 1 minus sine of x over 1 plus sine of x equals cosine squared x over sine of x plus 1 quantity squared. Okay, so there's a lot going on here. And so when I'm looking at comparing the left-hand side to the right-hand side, I can see that my denominator on the left-hand side is 1 plus sine of x, while on the right-hand side it's 1 plus sine of x times itself because of this square. So the first thought is, well, I can take the left-hand side and I can at least make my denominator match the denominator on the right-hand side. And the way to do that is to take the 1 minus sine x over 1 plus sine x on the left-hand side and multiply the bottom by another 1 plus sine x, because when I multiply those together, it gives me 1 plus sine x squared, which is what I need on the right. Now, I can't do that without doing it to the top as well, because what I multiply by here has to equal 1, and 1 plus sine x over itself is 1. So I'm, in fact, not changing the value of the left-hand side. I'm just multiplying it by 1, but a very special form of 1. Okay? So let's see what we have. So on the bottom, I get my 1 plus sine of x quantity squared, which matches what I wanted on the right-hand side. So hopefully what I get on top, this stuff, will match what I have on the top of the right-hand side. So in fact, these guys are conjugates, 1 minus sine x times 1 plus sine x. That means when you multiply those together, we're actually going to distribute now on the top. Notice I did not distribute on the bottom because I wanted the bottom to look like this, okay? So I did not distribute on the bottom. On the top I will, and there's a hint because they're conjugates that I might want to try that. So I get 1 plus sine x minus sine x minus a negative times a positive is a negative sine squared x. And so the fascinating thing about conjugates is whenever you multiply them together, the middle terms always cancel. Okay? So the plus sine x and the minus sine x is 0. And all that remains is 1 minus sine squared x, which we should recognize as being the same thing as cosine squared of x, which is what's on the right-hand side. Okay? So we end up with, on top, we have cosine squared of x. On bottom, we have 1 plus sine of x, quantity squared. And that is, in fact, the right-hand side. And that's the end of our proof. Okay? So we saw the power of conjugates there. Let's do another proof. Let's prove that 1 plus sine x over 1 minus sine x minus the reciprocal 1 minus sine x over 1 plus sine x, that big mess, equals 4 times the tangent of x times the secant of x. So a lot is going on here. So clearly the left-hand side is more complex than the right-hand side, but it both looks like they could use a little bit of work, right? So let's put them both in rehab and get them fixed up here. Let's take the left-hand side and try to combine these two fractions with a common denominator, since the right-hand side has no addition or subtraction. So we're going to take the 1 plus sine x over 1 minus sine x, and I'll leave a space there, minus 1 minus sine x over 1 plus sine x, and I'll leave a space there so that I have room to multiply each of these fractions by something so that the denominators, the resulting denominators, will match. Okay? So a simple way to do that would be to multiply this denominator by 1 plus sine x and multiply this denominator by 1 minus sine x, and you can see then that the denominators of the resulting products will match. Okay? But again, I have to do the same thing on the top of each fraction. So 1 plus sine x here, and 1 minus sine x here, because each of the fractions I multiply by has to equal 1. All right, so multiplying these together, the denominators match, so I know I'm going to get one big fraction where I've got 1 minus sine x times 1 plus sine x as my denominator. On the top, I have to multiply out all of this, so I'll put that result here, minus all of this, okay? So notice my use of parentheses here. I need to subtract the two numerators. So multiplying these together, I get 1 plus sine of x plus another sine of x. So I get 2 sine of x plus sine squared of x. Similarly, I get 1 minus sine of x minus sine of x, so that's minus 2 sine of x, plus sine squared of x. So let's clean this up a bit. On the top, this negative is going to distribute, so all these signs are going to change. And we can start to see that I've got a positive 1 here, and when this negative distributes, this is going to become a negative 1. So those guys, 1 and negative 1, turn into 0. Similarly, positive sine squared and negative sine squared turn into 0. And what remains on top is 2 sine of x plus, when I distribute my negative, plus 2 sine x. So I get 4 sine x on top. That cleaned up nicely. Now the bottom, if I go ahead and multiply this out, they're conjugates of each other. So I'm just going to get 1 minus sine squared x, no middle term. And we know that 1 minus sine squared x is the same thing as cosine squared x. So we've got our left side cleaned up very nicely. Let's do some work on the right-hand side and see if it turns out to be the same. I'm hopeful because this 4 showed up, which is something we have on the right-hand side also. So the right-hand side I could write as 4 times tangent, which is sine x over cosine x, times secant, which is 1 over cosine x. And if I want to multiply all of those together, I could turn 4 into a fraction, 4 over 1. And on top, I'd get 4 times sine x times 1, which is 4 times the sine of x. And on bottom, I'd have 1 times cosine x times cosine x, which is cosine squared x. So the left-hand side equals the right-hand side. And that is the end of our proof. Okay? So those are two great examples of proofs that involve conjugates.